Hey there, Mr. Chew in a tie, all dressed up with some geometry here. We call it geometry. I had a video request. One of my videos, someone said, could you please do a scale factor video? So I did an introductory one with some examples, and now these are the challenge problems. A reminder, scale factors is just a ratio of an image side over pre-image side of the corresponding sides. So make sure if these videos are helpful to you, that you like them. Make sure that you subscribe to my channel. There'll be a link down here for you to subscribe, and that allows me to get out to more people. So in challenge 1, it says find the scale factor of the dilation of each. Challenge 1, we have 2 rectangles, and since they're rectangles, you can go ahead and put all the right angles in here if you'd like. But the important thing is to make sure that you have corresponding sides. Now, corresponding sides are sides that are located in the same general area. So, since these dilations are the same shape, because remember, a dilation is an enlargement or a reduction. So, you start at one and it gets bigger, or you start at one that gets smaller. And our scale factor is going to be from rectangle A to B. So it went from the smaller one to the bigger one. So it's going to have to be a number that is greater than 1 because you're scaling it up. So, as we're going through this now, let's just go ahead and write the ratio of some sides here. So I'm going to take this vertical side and the corresponding vertical side. Now, since it's going from A to B, A is the pre-image and B is the image. So you put the image over the pre-image. So my scale factor is the image length, which is 15, over the pre-image length, which is 3, which reduces to 5. Now, I always like everyone to see this. So, if we take the horizontals, the pre is 4, and the image is 20. So that's 20 over 4, which still equals 5. Now, what does scale factor mean? It means that if I take the beginning pre-image length, and in this case, the beginning pre-image length of 3, and multiply it by the scale factor, I'm going to get the new corresponding side length, and you do. And then if I take the pre-image length of 4 and multiply it by the scale factor, I get the image length of 20, and that works as well. All right, so in challenge 2, and right here is my big boy. Here's my back. Can you see him? It's kind of hard to see him. See? He's a big boy. He's a big boy, 118 pounder. That's geometry, and that's who I name this curriculum after. Can't hardly see him, but he's a big boy. All right, in challenge 2, there was a little mistake when I was writing the problems down. This should have been a 7.5, and I wrote a 2.5. It wouldn't have worked. But now this will work. So, if we're going from C to D now, the bigger one is shrinking now. It's a reduction. So here's my pre-image, and here's my image. Now remember, when it got bigger, it's got to be a number over 1, and it was 5 times as big. Now since it's getting smaller, it's going to be less than 1. So it'll probably be a fraction. Sometimes they write them as decimals, but it's going to have to be less than 1, between 0 and 1. So remember, the scale factor is always going to be the image over the pre-image length. So we'll take this 9 over this 6. So the scale factor is 9 over 6. I can reduce that by dividing the numerator and denominator by 3, which is 3 halves. So you're saying, wait a minute, what do you mean it's 3 halves? So it went from, I need to flip that around, I did it wrong. I was going to say there's no way it could be 3 halves. It's the image, 6 over 9. So I know I would have gotten lots of comments on that. And I was going to think it through and I was going to find the mistake there. So I'm still dividing by 3. Since it shrunk, it has to be less than 1, and it is, 2/3. So you're saying, okay, but what about the other side? With that decimal, it's not going to give me 2/3. Well, we'll go on this side and this side, and we'll do it right this time. We'll go with the image first, which is 5 over 7.5. That's a weird looking thing, isn't it? Well, you never want to have a decimal in a fraction. So one way to get rid of the decimal is to multiply it by 10, but I got to do the numerator and denominator by 10. So that would give me 50 over 75. Now to reduce that, I divide them by the greatest common factor, which happens to be 25, and then that equals 2/3. So what did 2/3 mean? Well, what did it mean over here? We took a length from the pre-image times the scale factor equals the length of the image. So let's do that. Remember, if you take a pre-image length times the scale factor, that's going to equal the image. So let's see if that works. So I take my erase this and put it up here because it's kind of hard to see it when I get down too low. We said that we had the pre-image times the scale factor, and that's going to equal the image. Well, let's try this pre-image side of 9 times the scale factor of 2/3. So we're going to put that over 1. And we're saying that it equals 6. Now let's see if that's true. Well, 9 times 2 is 18 over 3. Does that equal 6? It sure does. All right, so now let's try the other one, just to verify it. So we're the pre-image, 7.5 times the scale factor of 2/3. Does that equal? So 7.5 times the scale factor, does that equal 5? So we put that over 1, multiply across, 15 over 3. Does that equal 5? It sure does. So these are scale factors. They're not that tough if you just realize that it's the image over the pre-image corresponding lengths. I'm Mr. Chu. This is Brack Geometry. Like this video, subscribe to my YouTube channel, and then keep watching my videos so I can help you with the geometry. And I'll see you next time in my next video.